In day 5, we're going to solve systems using matrices. So let's read the top. It says a system of equations will either have one unique solution, infinitely many solutions, or no solution. When you solve the system, you should be able to determine which type of solution you have. You will use a matrix in augmented form to solve a system of linear equations for unknowns x, y, and z. To solve an augmented matrix, you can either simplify so the matrix is in reduced row echelon form, or you can write the matrix as a system of equations and solve. If we take a look at example 1, we are given an augmented matrix. We have our coefficient of x, our coefficient of y, our coefficient of z. This represents our equal sign, and then our constant that's over there on the right. So what we're going to do is we're going to go ahead and write this into a system of equations. If we take a look at this first row, we have a 1 in front of our x's. We have a 0 in front of y and a 0 in front of z, which means we don't have anything there. So remember, these are our x's, this is our y, this is our z column, and this is our constant. So if we write what we have in this first one, we have 1 times x, which is just x, equal to 3. In our second column, or our second row, sorry, if we take a look at it, we have a 5 in front of our x, negative 13 over 3 in front of y, no z, and after our equal sign we have 136 over 3. So we get 5x minus 13 over 3y equal to 136 over 3. And in our third row, we have nothing in front of our x, so no x's, we have no y's, and we have 1z equal to negative 9. So here we know z is equal to negative 9. Now this one's nice because we already know x and we already know z. So what we have left to find is our y. Well, if we take a look at the middle equation has an x and a y. But since we know x is already 3, we can just go ahead and plug that 3 in here. So we're going to extend this, and so we have 5, and instead of x, we're going to replace that x with a 3. So just so you know, this x right here became that 3. That's where that 3 was coming from. Back to our equation, we have minus 13 over 3 times y, and that's equal to 136 over 3. 5 times 3 is 15, so we have 15 minus 13 over 3y equal to 136 over 3. Then what we have to do is subtract 15 from both sides. So if I subtract 15 from both sides, I end up with negative 13 over 3y equal to 91 over 3. And my last step is to multiply by the reciprocal, so I'm going to multiply by negative 3 over 13 on both sides. Negative 3 over 13. And I end up with y equal to negative 7. So I can say that my answer is x equals 3, y equals negative 7, and z equals negative 9. If you have any questions, please raise your hand and I will come around and help you.